Hello everyone. Today we're going to look at the values of the trig functions finding theta. So you should have already watched the video on finding the values of the trig functions. Now we're going to go and find theta instead. So before we can talk about finding theta, we need to start with the general inverse function. An inverse function undoes the original function f of x, and we denote the inverse function by f inverse of y. So we're going to look at some examples that we already know. Our function is x plus 3. So the question is, how do I undo that? I undo that by subtracting 3. And how it works is I plug in my function into my new variable inside my inverse function. So the function x plus 3 gets inputted into the y in the inverse function. And x plus 3 minus 3 equals x. So I have back my original variable x. What if we look at the function 3x? How do we undo multiplication? We use division. And again, I am putting my 3x in for my y, and I get out my original x. So this is the point of an inverse function. It's undoing the original function to get back the original variable. So here's another one, x squared. How do I undo the square? I take the square root. And again, I'll plug in x squared into y, and the square root of the square is the original function x, assuming that x was positive, but we're not going to get into that. So the next question is, how do I undo the function sine of x? Well, there's no mathematical operation that undoes the sine, so what we have is just the sine inverse function. So again, the inverse is denoted by what looks like to the power of -1, but there's a difference between this guy, which is the inverse, and then this, which is the reciprocal. So if the -1 power is outside of the function, then it's the reciprocal. If it's between the function name and the variable, it's the inverse. So again, sine inverse of y is not the reciprocal, because we know the reciprocal of sine is cosecant. So again, this is undoing the sine function. And how it works is, again, I'll plug in sine of x into my function. So sine inverse of sine of x is x. And this is, again, just by definition of an inverse function. It is undoing the sine. It's getting rid of the sine and giving us back our x. So we'll do one more. What if our function is cosine inverse of x? How do I undo an inverse? I'll do the original function. So the inverse of an inverse is the original function. So again, cosine of cosine inverse of x is x. So again, I'm always going to get back my original input, whether that input was an angle, such as it was here and here, or what I get out from the trig function, which, remember, is a ratio of sides of a triangle. So what this is basically saying is that if sine of theta is a, then theta is sine inverse of a. If cosine of theta is b, then theta is cosine inverse of b. And if tangent of theta is c, then theta is tan inverse of c. So if you look on your calculator, wherever your sine function is, if you hit the second of that or the shift of that, depending on what your calculator looks like, you will see sine inverse. Wherever your cosine button is, the same button, but shifted or hit the second, it will be cosine inverse. And the same thing with tangent. So if you have a sine, cosine, tangent on your calculator, you also have sine inverse, cosine inverse, tan inverse. So something to keep in mind is that, again, we're undoing the function. Theta is an angle. Typically we'll see it in degrees, but our A, B, and C are ratios of numbers. Remember, they're ratios of sides of the triangle, and there are no units associated with them. So if I have a trig function, I need to input an angle and I get out a number. If I'm using the inverse function, I put in a number and I get out an angle. So it's very, very important that you remember when to use the trig function and when to use the trig inverse function. If I'm looking for the theta, I'm looking for the angle, then I need to do the inverse function. I need to get rid of the trig function and just get theta back. And I do that by doing the inverse. So let's see some examples. So for now, we're going to assume that our angle is in quadrant 1. When we go into chapter 8, we'll see the angles from 0 to 360. But for now, we're just going to assume it's in quadrant 1. So if sine of theta is 0.866, I want to find theta. So whose angle will be 0.866 when I take sine of it? So again, by the definition of inverse function, I will take sine inverse of my 0.866 and I will get out theta. So on your calculator, depending on if you have the backwards calculator or the normal forwards calculator, you're either going to do sine inverse of 0.866 or 0.866 and then the sine inverse button. But we should be getting out 59.997 degrees. Remember, theta is an angle, so we need the degree symbol. Let's try another one. If cosine of theta is 0.25, what is theta? So again, my goal here is to get rid of the cosine and just find theta. So I do that by hitting the inverse function on it. So theta is cosine inverse of 0.25. And again, I can plug that directly into my calculator, and I get out that theta is 75.522 degrees. Again, it's very, very important that you remember the degrees because you are looking for an angle. And later on in chapter 8, we'll see angles that are not in degrees. So it's very important that you know that your angle is degrees and you put that degree symbol. If tangent of theta is 5.6, what's theta? So again, I want to undo the theta, so I hit it with the inverse. So theta is tan inverse of 5.6. And that gives me that theta is 79.875 degrees. So we'll do one more of the sine, cosine, tangent, the buttons that we have on our calculator. So sine of theta is 0.5. I want to get out theta. I need to get rid of the sine. So I hit it with sine inverse. So again, theta is sine inverse of 0.5. Theta is 30 degrees. Don't forget that you can always check your answer by plugging your theta back in and making sure that you do get out your 0.5. Most of these were rounded, so you might not get exactly, say, 5.6 when you plug in your theta there. But D, it's actually exactly 30 degrees, so you will get exactly 0.5. But you can always double check these guys, which is something that's really nice about it. So what if I have a trig function that I don't have a calculator button for? So I want to find theta when I know that secant of theta is 1.2. If I had a secant button on the calculator, I would have a secant inverse, but I don't, so I have to get around that. And I'll do that by taking the reciprocal of both sides. The reciprocal of secant is cosine. The reciprocal of 1.2 is just 1 over 1.2. So remember, the reciprocal is flipping it upside down. So if cosine of theta is 1 over 1.2, then theta is cosine inverse of 1 over 1.2. So notice with these problems, we are doing both an inverse and a reciprocal. Remember, reciprocal because it was a secant and I don't have the calculator button for it. Inverse because I'm looking for theta. If I plug this into my calculator, I have 33.557 degrees. How about if cosecant of theta is 3.25? So again, I don't have a cosecant button on my calculator, so I'm going to make use of the reciprocal, and that gives me that sine of theta is 1 divided by 3.25. So again, flipping cosecant, I get sine. Flipping 3.25, I get 1 over 3.25. If I know what sine of theta is, I can get theta by hitting it with sine inverse. And again, this I can plug directly into my calculator. And I should get 17.920 degrees. So let's try another one. Cotangent of theta is 4.8. Again, I don't have a cotangent button, and therefore I do not have a cotangent inverse button. So I'm going to take the reciprocal of both sides. Reciprocal of cotangent is tangent. Reciprocal of 4.8 is 1 over 4.8. Then I'll hit it with the tan inverse button because I do have that. So theta is tan inverse of 1 over 4.8. And that is 11.768 degrees. And as our last one, we have secant of theta is 2. Again, I don't have a secant button, so I'm going to use the reciprocal. Reciprocal of secant is cosine. Reciprocal of 2 is 1 over 2. And now I can hit it with cosine inverse. And if I do that, I should be getting exactly 60 degrees. And again, just like before, I can check these answers, plug in 60 degrees into cosine, and see if I do get a half back. So again, there's no reason not to check your answers. So make sure you read through the section, try the homework, and let me know if you have any questions. Thanks.